Hey everybody, Paul Abernathy here. Welcome to another episode here at Master the NEC for Electrical Code Academy. Um, Tonight's special for me because it is the launch of a brand new course, and we have quite a few that are coming here in 2023. People are familiar with our Fast Trax programs, but here we're starting to push forward with a lot of other courses, a lot of the programs. We've got some NFPA 70E stuff that's going to be coming out, and that's going to be a video series. We've got the new Aqua that came out, which is for HVAC technicians, and that is an extensive program, comes to the electrical portion. And of course, the reason for the live stream tonight is the introduction to Magenta. And so one of the things that we're trying to do here is we've split up all of our platforms, as you know, to where we have the Fast Trax Tube is our video platform. Fast Trax System is our new delivery platform for all of our courses, our Fast Trax programs. And we've even introduced some free courses over on the site. The Enclosures and Boxes course, it's on our regular website, that's free for anybody to do. But we're going to be introducing a lot more here in the next couple months, so it's kind of exciting for me to do these live streams. I don't do as many streams as I used to. People remind me that they miss the coffee hour, which will be coming back, but as we start getting into it and bringing everything forward. And of course, the Fast Trax 2023 edition is set to come out next month. So keeping that all in the loop. There's just a lot of stuff going on. So I thank you for taking the time to join me tonight as I introduce Magenta. Okay, so first thing off, let me give you a little bit of back history about Magenta, or why we're using the color schemes, because people keep asking why we're using color schemes. Be honest with you, the color schemes are easier for me to remember. So when I came up with the color, that was just the schemes that we use. There's no significance behind it. The black is our exam prep. The red is our residential. The green is commercial codes, electrical codes. Purple is grounding and bonding. Yellow is the electrical theory. And blue is industrial. So then we come out with magenta. Magenta is our industrial electricity. So what makes that different than, let's say, our Fast Trax yellow? Well, I'm going to show you tonight here in just a second what you're going to get with that. And it's quite astonishing what you're going to get with it. Now, a lot of the stuff in Magenta might be over your head. There's a lot of formulas. There's a lot of trigonometry type of equations. There's things that you might not be familiar with, but I don't want that to be something that's daunting for people. If you're at a very high level, then this is something that you really should embrace. But it is not to take the place. I don't know what that is there, so I'll delete it. So it's not there to take the place of anything other education you might get. And I have no idea what is going on here, why that's even popping up. But it's, one of those things where we wanted to create a course that was a little bit more detailed than our normal courses that we have. And so that's where Magenta came from. So I want to take you through it real quick and kind of give you a look-see on what Magenta looks like. So I'm going to kind of bring it up here. And of course, the console and the concept all really is familiar with folks that are in our Fast Trax program. This shouldn't be anything new. The whole concept of the layout is essentially the same. The flow of it is designed so that it makes it kind of, no matter what Fast Trax program you're in, you're not going to have any problem with it. Okay. The platform is built on the MindTap platform through Cengage. So again, it's a separate console for you to log into through our portal. And you get to see everything that's in there. So let me go on and kind of give you a rundown on what you're going to see in this program. Now, your course looks slightly different than this because this is my administrator. This is where I add certain things and stuff like it, but the concepts are still the same. So in Magenta, which is really just industrial electricity at a higher level, you've got your safety folders. Okay, so we're going to be talking about electrical safety. There's quizzes, everything involved, and we'll kind of dig into each one. But what's uniquely different from this and any of our other programs is the emphasis when it goes into things like electrical safety. Now, for example, I'll click on it so you can kind of get an understanding. So if you go to the table of contents here, you're going to see that we're talking 70E, we're talking safety in the workplace, arc flash risk assessment, which is also something we're going to be talking about in our NFPA 70E video series. It's going to be available over on Fast Trax Tube for those that want to subscribe to that. Use the 25 off to get $25 off that subscription. And of course, you'll get access to that series on NFPA 70E. But you'll see that even in Magenta, it goes into a lot. PPE talks about the different pieces of PPE, ladders, scaffolding, hand tools, test equipment, machinery, working on live electrified equipment, talking about doing that. And again, a lot of information centered around that. It's something unique for us to incorporate into a course, right? So that's going to be in here. So that's your safety aspects, and you're going to be tested on it. There's flashcards on it, quizzes and whatnot to test that safety. So it's going to be really good in a work environment. So if you have a company and you can have all your employees, if you're working on an industrial facility or a large commercial site where safety is key and paramount, this is a great course to get all of your electricians all on the same page, because not only is it going to cover safety, but as you see here, it's going to get into the language of electricity, and kind of, again, you have a bunch of different quizzes in here. But when you look at the language of it, again, we're going to be talking about things like drawings, one-line diagrams, schematics, how to use the drawings, all types of notations, and everything is going to be covered in this program. Electrical symbols, for example, you'll go through and learn all different types of electrical symbols that you might see on a set of drawings. It talks about the different types and everything in detail. And you just kind of go through it just like you normally would in one of our programs. Always got these you can pull up now that'll give you some definitions in case you're lost somewhere. But you'll start seeing all of these symbols, and this is a pictorial type of symbols that you might see, whereas it shows a dryer, shows a washer, shows a range, those type of things. But as you can see, you're going to go through it, each element of it, and then it's going to break it down into each piece. One line drawing, and then it discusses the one line drawing and shows you all the components that are involved. Now, like always, you can print anything you want, you can bookmark anything you want, and you still have the familiar README feature that is designed to read it to you. So all that's still here. Nothing is changing with that. You still have all that stuff integrated into the course, okay? Now that's just the language, kind of being able to speak the language, looking at the symbols and understanding, especially from an industrial electricity perspective. It's a much higher level rather than just pulling cable and just running conduit. You now start to get into all of the aspects of symbolization, pictorial images, things like that. Next you've got is electrical fundamentals. So this is important because if you go into electrical fundamentals, this is all it's going to cover. And this is what marries together with our Fast Trax Yellow, is that for an industrial electrical, you really want to have a firm understanding of things like the atomic structure, protons, neutrons, okay, all of those type of things. Current, what is current? Voltage, resistance, Ohm's law, work as opposed to power, apparent power. All those type of things are very critical as foundational stuff. Like if I click on voltage, here you see a long explanation of voltage. Now, that's important because rather than just tell you that voltage is electromotive force or pressure, here it kind of goes into a lot more detail with callouts. Okay, so there's a lot of things that you can click on now and you'll actually see it. So these have been incorporated, which some of you might notice this is different than our other Fast Trax programs, okay? And then of course you'll get some analogies, you know, pressure and how it works. And again, you'll get all kinds of additional information in the program, right? And you'll get resistance, same thing, talking about resistance referred to as ohms. All those type of stuff is in here. So one of the key factors is that you will be focused on fundamentals, but you're also going to learn the atomic structure and all those things that are important to get a better grasp of electricity. So if you think of it this way, we took the pieces out of the Fast Trax yellow that were important. We took the pieces out of the industrial wiring program and put that in here and kind of combined it, added the safety that is so critical to be able to make sure that everybody stays safe. All those type of things are all incorporated together in this. So that is kind of how it's expanded, okay? All right, so anyway, you've got that. And the next thing you'd want here is test equipment. So that is something unique, is that we're going to get into things like test equipment. And so we'll be talking about things like clamp-on meters, giving you descriptions of clamp-on meters. We'll be talking about showing you pictures of clamp-on meters, how they function, how they measure, how they're to be used. All different types of additional information will be shared with that, but that's not where it stops. Okay, we move into digital multimeters, explaining what they are, explaining how they're used. All kinds of different stuff is involved in this program. So you have a lot of icons, a lot of call outs in here, measuring voltage. Okay, explains how to do that with the meter so you can do it in a safe manner. So there's just measuring current, how you would use a digital multimeter to measure current step by step. So some of this stuff will be old hat for you. But then you might find some tips and tricks in here as well, because there's a preventive maintenance feature that's built into this as well. So Magenta's thought of pretty much all of those aspects of dealing with it, right? Okay, so let's kind of bring it back, because I'm kind of giving you this an overview. So there's and here's your insulation tester, pretty much referred to in the industry as a megger, because that's a manufacturer. But again, they're typically the widely known. There's other Flukes and Fleers and all types of other manufacturers. But anyway, you'll go into some information and talk about those. And of course, safety precautions when you're doing an insulation test, things to be aware of. So this is great safety caution for the end user, guys that are on the site, people that maybe you're the owner and you have to make sure all of your people are trained properly in the use of the different equipment. This is going to go a long way towards that. Plus, these can all be printed off. You can bookmark it, do whatever you normally could do in any of our Fast Trax programs. So it goes all through the test equipment, and then of course it's going to quiz you on it, and then there's an essay. You know, the thing that's unique that we're doing for the first time is using an essay format. Now, our CMECP program, and also I want to say this while I'm live, I would like to say that William Buds, I'd like to congratulate you. You're our newest CMECP. Your essay was reviewed and you received the proper number of votes. So I'd like to send an amazing congratulations out to William Butts for becoming our latest CMECP. So congratulations, William, and welcome. All right, let's get back in it. So, okay. So you've got quizzes, you've got flashcards, you got everything, even on test equipment. Now, starts to get into things like basic resistive electrical circuits. So I'll show you an example of what that covers. So it's going to talk about an introduction. It's going to talk about series circuits, parallel circuits, combination circuits. Again, while electrician may not worry so much about series and parallels, maybe for an exam, but in the real world, you don't think about it too much. But if you're doing lighting and you're doing other things, it's important to know the concepts of series and parallel circuits. So for example, if I click on that, it gets you the beginning and starts explaining it, and will give you a real practical aspect of what a complete circuit is, what a series circuit consists of. And then of course, then it'll start introducing different loads. And what I like about the program is rather than showing you a bunch of resistances and stuff, it tries to incorporate it in a way that you can relate to it in the field, right? Real use applications, the loads being lamps, or light bulbs, if you want to call them that type of thing. And here you talk about the series. When it's closed, they're lit. When it's open, they're dim. And it talks about it, and then it'll begin to go in how you calculate this out and how to do the math, if you will. And here it starts introducing you into the different symbols for resistance. And then of course it kind of says, okay, we'll take the lamp, which was a resistance value. Now we're going to make it a resistor for to start learning the principles of what it is. And then you get into the formulas. And then, for example, here you'll start looking and setting a value. So this is unique for us because in the Fast Trax yellow program, you're pretty much dumped into different values. But something that's unique about Magenta is that the scope of the material, it is so well put together. I mean, it takes you through series. Now, you get finished with this, you're going to understand series circuits, but you're also going to understand how it relates in the real world. And that's what this is about, the real world application with great illustrations. Some of the best illustrations in the industry are in Magenta. Okay, so we're excited about it. And it's, again, see how it walks you through step by step, explaining the formula. And here's another way that it's breaking it down now into what we call line item type of calculations, where it's showing you when these values are known, and then you're solving for this, and it shows you the equation, and then it works the equation and things like that, and gives you another example. Okay, that is unique to the program that really isn't done that way in our other programs. So we're excited about what Magenta brings to the table for that, if you need to learn the concepts of series and parallels and all those type of things. So, all right, so anyway, it goes over series and parallels, and again, we'll test you on it and quiz you on it. Next, you get alternating current. So now in alternating current, people say, well, what will we learn in alternating current? Well, you're going to learn basic AC theory. You're going to learn the generation of a voltage curve, phasor diagrams, again, that old pesky trigonometry. I recommend you don't get too deep into this unless you have an extensive background in trigonometry, because it is going to drive you crazy with the formulas, but it is there. The key thing is understanding the basic concepts of electrical theory, and then you can start moving into things like effective value, average value, instantaneous values. It'll even show you how to do that with phasors and using vectors and all that stuff if you're interested in it. But then one of the more important parts of it is here. It starts getting into electromagnetic induction. And that's kind of some of the basic principles of the AC circuit. And it starts showing you these curves and explaining what they mean. And it's just really a lot of diagrams. And again, I'm not going to lie. This course is not for everybody, okay? Because you really have to focus. If you can see here, it starts talking about cosines. And then, of course, in vector graphics, as I said, and you have to start understanding those relationships. But I wouldn't get too lost in the weeds with it, because it ends up going through and explains how to put these pieces together and actually works the equation out, okay? So that is one aspect of it, but it gets very deep into that. Now, it continues on into reactive circuits and power factor. So you'll be talking about inductance and RL circuits. You'll be talking about capacitive reactance. You'll be talking about power factor correction, three-phase circuits, three-phase power correction. So just to kind of look at three-phase circuits, it's kind of going to go down and explain how the windings and how it works. Whether or not you're talking about a three-phase dealing with a stator and a rotor and the number of windings that would be in the stator versus what you have in the rotor. All different types of aspects that it's going to talk about in here, and it's going to show you how it works in conjunction with a full cycle. Here's the rotation of the armature inside of a three-phase. Okay, line 1, line 2, line 3. You get to see the setup here, and it starts talking about it and gives you some little things to remember. Okay, like a three-phase transformer of the same frame size as a single-phase transformer has approximately 150% more capacity. So, same frame size, but a three-phase transformer, because of its nature, is going to have more capacity out of it. It's more efficient than a single phase. So, there's just so many things that you'll see in here, and things will start to make sense. But I will tell you, these are not basic concepts. So, if you are somebody that's just getting into the industry, this is not the course for you. Magenta is not. If you're somebody that's really wants to know the different aspects of it at a much higher level, and you love formulas, you love dealing with all that stuff, we never stop learning. And so there is concepts in Magenta that you might have never thought about, and it just gives you the opportunity to look at it and get the benefit of that. Now, you get access to Magenta. I should have said this. It's just like any of our Fast Trax programs. You get access for an entire year. So you can go at your own pace and go through it and work through the entire course if you want. All right, so anyway, you'll go through that. And in the course, it gets into conductor types and sizes, because no good course would be complete without talking about things like circular mills, square mills, American wire gauge, resistivity, thermal effects, again, correction factors, insulation types, all these different things, splices, terminals, terminations. If you just click on splices, for example, you'll see it talks about different splices, talks about different ratings, and everything, and you just kind of move through it. It'll talk about the different splicing devices. These happen to be wire nuts, which is a trademark of Ideal, by the way. But there's other ones like Gorilla Nuts and other types of things, crimp splices, all those type of things you'll see different examples of. And they're just all through the program. Talks about terminal connections, okay, looping, back wiring, all those type of things, lugs, okay. So anyway, that's just other pieces that are in here that are just packed with so much additional information for you to learn. Now, you've gone through the sizing. Next, you have a segment here that talks about electrical installation. Yeah, so in this one here, I'll just kind of give you a rundown. So in this one, you're going to get in depth in things like AC cable, MC cable, non-metallic sheet cables, service entrance cable. Very little non-metallic sheet cables used in industrial. But again, it goes into and explains it. Raceways, different fittings, conduit bodies, boxes, conductor installations, selection and sizing, color coding, high leg markings, raceway sizing, cable trays. For example, I click on cable trays. And here it kind of goes, if you're not familiar with cable trays, which are used a lot in industrial applications, then you'll have ladder type, ventilated trough. You got ventilated channels, solid body, all that. And it kind of goes through and shows you what they look like if you've never seen them before. Kind of gives you an idea what it is, okay? And then, of course, you'll get your summary. All right, so then you go through the different, then you got magnets and magnetism, transformers and electrical distribution. So just kind of looking in here, kind of give you an idea what's in the table of contents. You've got principles of transformers, current regulated under load, voltage regulation under load, capacitive, inductive effect, turns ratio, losses and efficiencies. Sure, we'll talk about hysteresis losses, transformer construction. So this goes into understanding the construction of a transformer, the different effects that you might have of how it's constructed from a primary to secondary effect. You've got special transformers like auto transformers that are covered in here, buck and boost transformers, talks about the different connections, series, parallels, three-phase connections, two-phase, isolated. a lot. It even gets into like delta, delta Y, 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 delta Y, delta connections. And of course, it even gets into primary distribution system as well. And then, of course, the grounding associated with all that. And it even talks harmonics. So harmonics, again, sometimes is difficult. I have an article coming out probably next week on harmonics that you might be interested in. But again, this kind of discusses harmonics and gives some insight into what it is. All of that's in here. DC machines, AC machines. If I go under AC machines, kind of give you an idea what the table of contents here. It's going to talk about single phase alternators, two phase alternators, three phase alternators. That is your power source, like what you use in generators. You've got phase sequence, explaining what that does and how that affects the system. AC motors, three-phase motor theory, and it talks about determining rotor speed, direction of rotation, speed of rotating magnetic fields. Even discusses slip, which has some relationship to torque, okay, and things like that on a motor. It'll talk about things like squirrel cage, wound rotor, adjustable speed, induction motors, high frequency motors, synchronous motors, but even gets into single phase motors specifically, okay? And it talks about the different values that you might have. So as you can see, it goes deeper into motors as well, not just AC, but DC as well. So there's an actual module on that. So again, a lot of information to absorb, but it's all there for you for those that are interested in it. So then let's kind of go on here. So you've got control and control devices. So a lot of people that actually do exams, there's a lot of stuff on exams sometimes about controls and control devices, and people kind of forget what they are or lose sight of what we're talking about. So again, this is not an exam prep course by any means, and do not buy this course if you think it's something for exam prep. It is not, okay? But it gets into things like control and control devices. So it's going to talk about push button, rotary switches, limit switches, proximities, photoelectric switches. It even talks about control devices. And again, like contactors, relays, time delay relays, all of that is all covered in this unit. Okay, so if I were to just click push button, okay, then it's going to give you, again, show you an example of what a push button is, give you some information on it. It's a momentary switch, okay? And you're looking at it, and it talks about the normally closed and normally open contacts and gives you an explanation on it. And again, you also have these pullouts here where you click it and it brings you some information if you have a question about what it means. Normally open versus normally closed contacts. Okay, so there you go. There's a mushroom e-stop push button. Okay, so break before make and make before break contacts, discussion on that as well. And then illustrations to kind of hammer it home. All that's in here as well. So if you've got a need to learn about control devices and the different types of control devices, then this is going to be right up your alley. Then you've got motor control circuits. So motor control circuits. So we look at the table of contents here. We're going to be talking about this. It talks about 2-wire control circuits, 3-wire motor control circuits, multiple stop-start controls, forward and reverse controls, speed control, all these things that as an industrial type of electrician and working with industrial electricity, you're probably very familiar with things like speed controls and multiple start-stop station applications. And this is something that you're going to need. It's going to be invaluable to add to your repertoire as you start to learn these things. Now, remember, you can literally print anything you want. So if I click on this multi-stop start right here, okay, and it shows a diagram and it starts to explain it, as you see, it makes reference to the diagram as it's explaining it. You can print right here anything you want. When you click that right there, it'll create a preview here on the right. It's kind of behind me, but you see that and you click that print button right there, and it's going to print it all out for you. The drawing, everything from this. You can print out every single, every page of the book if you want. That's up to you, because again, If you want to print it, go for it. All right, so anyway, you'll get on all those type of controls, but that's not it, folks. What about variable frequency drives and learning the different types of variable frequency drives, different use and applications? Well, there you go. The need for variable frequency drive, the history of it, what they're seeking to solve, the different types of variable frequency drives, installation, physical mounting, how the grounding requirements for variable frequency drives. I get calls about that all the time. Wiring cable requirements for variable frequency drives. I get that question at Encore Wire all the time. So if you go in here, it'll start talking about power cables. It'll show you some information, how to create separation so you don't get talked back onto any of the components from the VFDs that could cause problems or induce voltage. All these other different types of aspects are kind of discussed in here, but not so heavy that it overwhelms you, right? It's just kind of a good discussion of variable frequency drives, for example, right? And it kind of goes through and gives you some information and notice, and then it gets into programming and talks about, well, how do you program them? And again, kind of has a discussion on that type of information. So just an awful lot to cover in it, but it is there. As well, you have obviously flashcards as well. And of course, you do have some quizzes and the essays. Now, I was going to show you what the essay looks like, but we'll show you those on one of them once we get to the end real quick here, because we're almost there. Now, PLCs and PACs, you got a lesson on that as well. And so that's going to cover PLCs versus PACs, what the PLC components are, the input and output modules, programming, all this type of information is here. Okay, so again, you're going to get information about that if that's what you do, or you're trying to work on that area of your skill set. Then you're going to get some training into PLCs, and then of course lighting. So lighting is very important when it comes to industrial as well. So you're going to be talking about lighting management. You're going to be talking about the distribution, glare, layouts, the different types of luminaires that you're going to encounter, from fluorescent to incandescent to light emitting diode lighting, LEDs. There is even a comparison. There's maintenance tips in here, as well as a relamping. But if you did a comparison, for example, it'll break down and we'll start to compare here in this chart for what application, right? So again, you get some comparisons between the two. Again, you can print any of this you want out at any given time. And of course, we're going to end up on chapter 19, which is preventative and predictive maintenance. And this is pretty cool because this is going to give you some rules, some charts, some inspection reports, kind of things to follow, some tips, some checklists, all those type of things to look for preventative maintenance on a industrial installations. But one of the neat things is you have a checklist, and it kind of goes down the checklist, right? That's one unique thing with it. And another interesting one here is PE maintenance concerns. So it'll take you through the various aspects of maintenance concerns, from the drawings to test equipment. All those type of things are all in here as well. Just good, solid information. All right, now comes to the essays. Let me give you an example here. So let's just do alternating current, and you look at the essay. I just want to show you what this is, something that's different than what we've done before. I'll start one of the assessments here. Now, interesting, you see here that there's 19 for this assessment. Here it says, list the 4 factors that determine the amount of voltage induced into a coil that is rotating in a uniform magnetic field. Okay. Now, what happens with this is you're going to put your answers here, and you can do what? Remember, folks, you can also, and people forget this, you can also open the book at any time, go into this, and you notice that it's asking about the 4 factors. Well, you're over here in your book here, right? And you're talking, the question is asking about the magnetic field, okay? So you're over here in your unit, and you can pull anything you want at any given time from your course material, right? So if you want to pull something over here that's based on chapter 6, then you're in chapter 6, then what you do is you'll go hunting for it in here. And when you do that, this is going to allow you to be able to get the information from here, and then you can put it here. Now, let's say you put your information in, and it's what's called self-regulating process here, is that you can click right here to check your work, and it will take you to where you need to be, okay? So in this case, you're here, and it's going through it, and it'll start you off where you need to be in the location, and you can move your way through here, and your information is going to be found as it moves through these pieces here, okay? So as you're going through everything, you'll see everything here, okay? And here, the amount of voltage produced by a coil rotating in a magnetic field depends on the following factors, right? So these are your factors, okay? Now I could do these, right? And I could have taken this, and I believe I can do that. And then if I go over here, I can paste them in here, okay? And when this is happening, what you're doing is you're just kind of reiterating everything, okay? And checking your work. And it does get submitted, so you can submit your course for grading, and we will grade it. But the purpose of this new style of essay is for you to type it in using the course material, try to search for the answer unless you just know it, and then you put it in here, and then you can verify it by clicking here, and it will take you to the beginning of where you need to search for your information. And you just got to read it. So it's trying to make you read it, okay? Now, if you don't want to do this, okay, then you can simply just put in your answer and you could submit it for grading. That's your choice. And we will give you back that information. But this is kind of one of those things where you get to work through it yourself and do the course material, okay? Same thing, well, here you see I clicked that right there. All right, and there's your course material. Then you go to the second one, same concept. Define effective value of an alternating current. Okay, so remember what we said, since you're working in Unit 6, if you didn't know what it was, you can go over here to Unit 6. All right, and here is effective value, right? What is effective value? Define it. Effective value here. Right, and you can Control C, and then you go right here, paste it, and there you go. Okay, and if you want to check your work, and when we say check your work, this means that you can look to see if it puts you at the right place, okay, before you were to submit your work to be graded. This allows you to be interactive. Go look for the answer. I don't expect you to memorize it. Go hunt for it. It's in the course material. But if I check my work, here you'll see that there is it. Click this, and what it's going to do is going to put you in a location where you're right ahead of what you need, and there you can see it geared you up, and that's the information. It's really wanting you to do two things, because this is difficult stuff here. It wants you to go back and read it again. And then you can cut and paste it in here, unless you want to type it in your own words. But really, our grades don't matter. It really doesn't mean anything. It's the ability for you to move in and out of the course material and be able to use the book at the same time. That's what it is all about. You go to the next one. What does the letters RMS represent? Okay, so root means square. But if I didn't know that, okay, and you could type that in here. I could type root means square, okay, right? And you could submit that, or you can check your work, right? And you notice it says that you're checking your work. So answered needs instructor grading. So we're going to be grading it, but that's what you're submitting. But your best chances of getting the best grade, and again, us knowing that you understand the information, It's like, okay, well, I'll go down here and click on this. And this should be right at the beginning of it. And there it is, right at the beginning. And there you go, root mean square, which is RMS, okay? And that's just another name for effective value, by the way. You can call it effective value, or you can call it root mean square, okay? So again, this is what we really want you to do, because by the time you do this, when you finally submit your grading, you should have 100%. You see the concept? So this is new for us. This is essay style. We want you to put your answer, and if you don't know the answer, we want you to use the feedback and check your work, all right? And then go down here and go to the course material, okay? That's what we want you to do, okay? So it's a little unique for us. Never done it this way before, but this is something that's new, and it's requiring you to try to answer it. The course material's right there. I don't expect you to remember all that. That's different than exam prep, folks. This is some heavy stuff. You want to use the book. So you want to take it, go to the course material, cut and paste it. That's perfectly okay. It's acceptable. It's not like you get deducted if it's cut and paste. If it's in your own words, you don't get extra credit. Okay? That's not the purpose of this program. This course is difficult enough that you don't want to have to make it more complicated than that. Okay. So anyway, there you go. So that's our essay style. Now, beyond that, we have the normal quiz, just so you know, because I know some people will say, well, do you have some quizzes that aren't submitted as well? Yeah, sure. So they're in the same format. And here you see there's 22 of them. Okay. So an alternating voltage is an EMF that is continually changing in value, alternately reversing direction. Both of these answer choices or none of these answer choices. Now, let's say you're sitting there and you're in the course material and you're saying, oh, EMF. Now check this again, right? Check your work, okay? It says incorrect because you did not check anything, right? It wants to at least, I wanted to show you that, it wants you to at least to give it an effort, okay? It wants you to try. So electromotive force, okay, is something that is reversing directions, let's say. So again, watch me check my work. All right. Oops, it's incorrect. Well, in that case, you should have the ability to click here. I wanted to show you this. See this? If you get it wrong, you won't get this if you get it right. That's why I want you to see. Here, click this, and then you see what happens if you right click it. You go up here and then you click introduction. And then introduction will take you to where you need to be. And here it starts talking about what it is. Okay, it starts talking about the sine wave. Let me pull back here. And it'll get you where you need to be. And you'll scroll down. You'll see hertz, frequency. Okay, and you just start moving through. And you'll find your answer. But it's going to make you read the material, okay, in order to be able to find that. Now, let me give you another tip that you can use here when it comes to this. Get you here, okay, is one of the other things you can do is go up here. You know, you're in the course, but watch this. I didn't show you this. You have a search feature, and I usually forget to show this to people. If you type EMF here in the search feature, it's going to bring back some search information, right? And here it gets into EMF gives you some reading material, AC machines, EMF, okay? All this alternating current, EMF. So you have a lot of information that you can pull from in here. And let's just click on this material. And this takes you here, and you can read all about it here in the EMF, okay? So extra information. Now, another thing about these quizzes, I'll take you back to it. All right, so we're back in here. Okay, so if you were to check your work, now again, the real answer to EMF is that it is continually changing in value and it's alternating, reversing direction. Okay, so, but here you see this. If you hold this over when you get it right, look at the explanation. Correct. The standard AC generator produces a voltage that increases from 0 to a maximum value in one direction. That's the peak. and then drops back down to 0, and then increases to the maximum value in the opposite direction, which is I like to say sub peak, but it's the lowest max value, and then it comes back to 0 again. That's one complete cycle scenario. So the good thing about this is when you do that, you actually will get the little green, and it's still going to take you, if you click it, it still can go to the introduction and read about it if you want. Same thing here. Let's just show you another example of one where we might get it wrong here. So the number of cycles of an alternating voltage completing in 1 second is called the fluctuation, the frequency, the alternation, or the hertz. So what do you think it is? Okay. So if I click here and I check my work, you'll see that that's incorrect. Here you hold this over it and click it, and then it'll take you to basic AC theory. Okay, remember what we were asking about. You click on it, and here is talking about alternating current. Okay, and explains it, going through it. Frequency. Here you go. Ready? The number of cycles completing 1 second is called the frequency. Right? So the answer to this question was actually, close that down, is actually frequency. Okay, and then if you correct your work, you see that you can actually now click on it and you'll get an explanation. So this quiz is not so much worrying about score. It's to test your knowledge, but it's interactive. Okay, so if you get it wrong, and I can click hertz and then check my score again, and you'll see that it marks it wrong. And then you can click it, and then you can go to where you can get the answer, right? But see this little mark right here? If I click frequency and I check my work, notice it checks it as correct, okay? It's answered correctly. And you click on this, and it gives you some explanation that you could have hunted for. So this is kind of something that's new in this process. To be able to go through. Most common frequency used in the United States is 60 hertz. 60 cycles per second. But if we checked 50, you could submit this if you want without checking your work, and it will be graded at the end. Okay, not a problem. But I encourage students to work through it and check their work on each one. And that way they can use these, if it's wrong, they can use this to pull up the course material, or they can click this and then they can read it when they get it right. But there's another way to do this as well. Let's say I get to this one right here. All right, it says the modern unit of measurement for frequency, which means cycles per second, is what? Watts, farad, hertz, or Henry. Now, if you want to do this and you don't want to do the checking and guessing and use this to learn those type of things, then you simply would open up the course material, and then you would go to that unit. Since you're working on unit 6, you would go to unit 6. And since the question is dealing with frequency, then you're going to go down here and you're going to be looking at what answers can get you the answer you need, or you might have to go looking into it to find what you need. So that's pretty much probably going to be under the introduction. Okay. So as you go through the introduction, you're going to be introduced to the motors. You'll be talking about cycle, hertz. Okay. So the modern unit of measurement of frequency is hertz. And that's the question here. So you're going to answer it. You can close your course material. Now, if you don't want to review it yourself and see how you did, then you just keep going to the next one, and it can be submitted if you want. But I recommend that you do this. You check it. And if that's right, you click on it and you can read it again. All of this stuff hammers this home. It's just making sure you check yourself over and over. This isn't the same as preparing for an electrical exam. Here, it's okay to check your work. If it's wrong, it's okay to click the button and go looking for the answer. Your course materials right here. That is the thing about Magenta, is there is so much here. There is no way that you're going to memorize it. And you should be able to move in and out of the quizzes without any problem. Okay? We'll do another one. The standard AC generator produces a voltage that, when plotted on a graph, produces a cosine curve, a frequency curve, a sine curve, or a tangent curve. Okay, so if I choose sine curve, again, you could submit it, or you can click the grade, and you see that that answer is correct. Click it here, and here it'll give you the explanation. Now, let's say I got it wrong. Let's say you clicked that one, and you checked your work. Again, you can click on the X, and this should take you where to find that information. Click it. And here it's going to start talking about, again, this is basic theory. So we're asking about that. So you're going to see cycle, frequency, hertz, okay? Keep on going through it, and you're going to see all this information. This is just a pictorial graphic of current flow. And here's your voltage curve, and going plotting it, things like that, talks about it. And again, it shows you the ratio and everything. And as you keep going, you'll eventually get to where it talks about the actual plotting. Okay, now it's trigonometry, that type of thing. So, you know, it gets kind of deep from there. But again, you've got all this information here, just kind of works you through it. All right. Let's see here. Let's see. So we know that that is a sine, so we can just check our work. We know that's correct. You go on to the next one. Okay, a vector is a line segment that has a definite length and direction, a series of curved lines, a triangle, an arc. Okay, so a vector. So if we wanted to know what a vector was, and let's say you didn't know the answer, now you could do like we did, or you can go over here and open it up, and you go to your table of contents, and since we're in unit 6, we're going 6, and you go down here, and you're looking at all these different answers right here. So you're trying to say, okay, I'm going to have to find out what the vector is. So again, if I trip trigonometry and I go through and I'm looking here and I'm seeing all these, all right, and let's see here, there. Oops, I think I'm going to go back. I think I went to the beginning of it. Okay, a vector. So a phasor is a vector, represents varying quantities such as current and phase. It means by means of a line rotating about a point in the plane. A vector, okay, is a line segment that has magnitude and directions. Okay, so a line segment that has a defined length and direction. Okay, so again, it looks like that. So we're going to check our work. We're correct. Click on this. Here it talks about that. And if we click here, and I'll shut this, click this. And here it brings you to the start of where you want to start reading. And you want to keep reading until you find your answer. It's not going to take you right to it. Okay. You want to read through because it's basically forcing you to read the material again. And here you see vector, that was in the question. And if you read it, you can get the answer from it. Okay, so that's kind of the mentality of how this works. Okay, so enough of that. But use those quizzes, practice with them. Same with the essay, works the same way. But that's what's in the course, folks. Now, just like always, you've got glossaries. Okay, this is interesting, be able to learn the different terminologies, so that's great. You've got your study hub, which is where if you bookmark something, this is where it's going to appear. If you highlight something, that's where it's going to appear. Here, you can change this cadence of the voice if you want it to read it to you. That's fine as well. And to grade all your work, it'll be down here in the progress. Click on the little green progress wheel, and this is where you're going to have all of your grades that we might grade if you don't want to grade them yourself, right? If you don't use self-grading, that type of thing, okay? All right, folks, that's it. That is Magenta. I know I couldn't do it justice. It's so much involved in it that, again, it's one of those things that's just kind of a lot of information. Now, I did get an email from somebody who asked me to show very quickly, wanted me to show the new course for the HVAC. And I wasn't necessarily ready to show the new course for that, but I'm going to see if I can't pull it up real quick and show you what that is. If I can, bear with me here. see if I actually set that up in my program to be able to demo it. And I don't know that I have, but I believe I did. So let me go on and get over to it, because that one's unique as well. So this is Aqua, right? So let me bring up Aqua. So here's Aqua. I know weird names. I get it. So Aqua is designed for people, electricians that'll be working with refrigeration, heating and cooling, and those type of things. And they need to know about electricity. So this one's pretty neat too, because this one goes over safety, basics, circuitry, meters, symbolism, schematics, drawings, diagram, AC power, basic motors, components of electric motors, contactors, relays, overloads, thermostat, pressure switches. As you can see, it even goes into troubleshooting, residential, installation of heating and cooling, and of course you've got troubleshooting modern refrigeration, heating and air conditioning, control circuitry and symbols here. And you see all the stuff that's involved here: diagnostics, troubleshooting, how to troubleshoot a circuit, using troubleshooting charts, things like that. Service calls, scenarios, what do you fix when somebody calls and says this is going on or that's going on? I'll give you an example. So here's an example of a service call where it's not cooling enough, right? And so it talks you through what the technician would do. So this can be invaluable to technicians who go out on jobs for commercial industrial cooling systems. It even has one for residential, all of this. And you can print all of these off as well. So the other neat thing here, and we really don't have time to get into it, is the simulators, right? So there's some simulators in here that you can do some simulations. So I just click on it. I don't know how well it will load, by the way, because again, it's very dependent on your connection. But I'll go on and click on it and see if it loads. And while we're waiting on it, this is a simulation that allows you to test with different test devices and things like that. So if you've got technicians who are training or learning, then they can utilize this product, right? So here's an example where you'll get a bunch of information in here, and you can do the tutorials. And here's the electricity one, and it's got some videos, that type of thing. All right, let me get past this. Okay, so this kind of goes, this is an explanation of how to use the course, see? So here's some tips. There you go. See, it kind of gives you directions so you know how to do it. Let's see if I can share that with you. Here we go.
At the bottom of the screen, you'll see the control panel for the wiring diagram. Each element is adjustable. The system switch turns on and off.
Okay, so
the fan switch allows you to
real quick. So that's just a tutorial on what the pro course is like, right? So for me, I will take you back through here, and let's see if I can get you back into the tutorial, just so you can see what it looks like. Right, so here, for example, it's trying to show somebody that's new to the industry. It's trying to show them the different circuitries and things like that. So what you don't see is behind quite elementary, right? That it's basically just walking through the steps. This is just the basic. As it gets further in it, you actually will troubleshoot an AC system, air conditioning, heating system using these meters, and they'll simulate breakdowns, and you will use the meter to determine how you would test it. You do this over and over, and then when you get out into the field, it becomes easier to understand how you would use a test device, that type of scenario, right? So it's pretty neat. It's kind of a unique little product here. So you follow the steps, and there's a bunch of them, folks. So now this is displayed. It says 120 volt. It's displayed on the meter. That's what you see. That's the voltage. Now let's examine the current in amps. Okay. So next it says, go and do what? Click on the left-hand current. Let's see here. I got to go back previous. All right. Let's see here. Let's examine the current measurement in amps. Click on the amps setting on the multimeter. Okay, so now I got to change to amps. All right, so now it becomes a clamp-on meter. And I'm going to clamp it to this side of this circuit. I'm going to clamp it right here. And that's going to tell you that it's pulling 0.125 amps. Okay, this is a 120 volt source, right? And it's going through a 240 volt lamp, and it's going to be 0.125. Now it should be the same on this side. There you see, it's exactly the same. So basically you just follow the steps. Now this is just basic. It gets more in depth. And so this is pretty cool, okay? Because you can change different values here, okay? So if I were to take this and make this 240, see how that burns bright? And notice that the amps increased. Now click it on this side. Notice it increased. Well, it doubled because it went from a load, which was the 120 volt, now it's 240 volt source. Okay, so again, you see here, you can move it around as you want. But anyway, that's just a neat feature. Figured I'd show you folks that. But that's just a simulator, and that's included in that program as well. And it gets deep in diagnostic. Plus, there's a lot of those videos that show you how the tutorials work and how you can diagnose a system. So if you're in that HVAC world and you're doing the electrical component testing, this is the course for you. It's not going to be for everybody. But I just wanted to show you what Aqua was all about because we hadn't planned on doing any separate video for Aqua. It's just an extra course that we're making available for everybody. Okay. Now, I did tell everybody that I would do a discount code for Magenta, but I'm going to have to renege on that promise because I'm actually going to put the discount code in the description of this video once it's published. The reason is we're having a little problem with the coupon code in our system. So we transitioned over to fasttracksystem.com, and we never implemented a coupon system. We have coupon systems up on our Fast Tracks tube, right? But we never introduced anything over on the Fast Track system. So I got to get that squared away. So I encourage you to check the description later in this replays, and you will see the discount code. Now, if you want a discount code for Fast Tracks Tube, then that is 25 off, okay? And that's our video platform, okay? Fast Tracks Tube, where we're gonna have the new NFPA 70E training series. That's coming up. If you wanna get that, just use coupon code, 25 off, and register for that, okay? All right, folks, that's a lot of information in a short amount of time. I'm sure we'll do other individual training on Magenta because it is very extensive. But hopefully you got a little bit of a sneak peek on what it's about. I know my thumbs out folks out there have already given me that. I get it, but hey, it's all good. Until next time, folks, stay safe. God bless.